The first property that we have to deal with is your density. So let's understand this density. What is the physical significance of this? So see, in this particular diagram, I have taken a cubical block of 1 meter length, 1 meter height and 1 meter depth. So the volume, as you can see, is 1 into 1 into 1, which is 1 cubic meter. And some laddus are present inside, maybe some rasgullas or laddus. These are nothing but your molecules, or rather some matter is present inside, or mass. So what is mass? The mass is nothing but the quantity of matter present inside any body. So inside this particular cubical block, so the quantity of matter which is present inside that, so that is your mass. And how do you define matter? So matter can be defined as anything that has mass and can be perceived by our senses. Alright, so this is the quantity of matter present inside that, and let's say we have calculated or measured the mass for this particular cubical block as 20 kg. Now this 20 kg mass is present within this unit volume. So if this 20 kg mass is present in this unit volume, so this particular mass present per unit volume will be considered as your density. So density is nothing but it has been taken as the ratio of mass and volume. Okay, so and that to a unit volume. Now let's see here, we have taken a big cubical block out here, and the volume for this of the big cubical block, we have 5 into 5 into 3, which is 75 cubic meter. Okay, so this is a big cubical block whose length is 5, then height is 5 and width is 3. So if you measure the volume will come out to be 75 cubic meter. Now let's consider we have got a unit volume at the corner. So how much quantity of matter is present within this corner of unit volume? So this, we are not interested in the entire volume, rather we are not interested in the entire mass. We are interested how much mass is present in this unit volume. So that unit volume plays a vital role in calculating the term called density. Okay, so the question is, how much mass is present in that particular unit volume? Unit volume, that means unit volume. It could be anything. It could be 1 unit cubic meter, or 1 unit cubic centimeter, or 1 unit cubic kilometer, anything of any unit, but it should be unit. That means it should be one single. The volume unit could be anything. It could be cubic meter, it could be cubic centimeter, it could be cubic kilometer, doesn't matter at all, but the value or the magnitude has to be 1. That is the important thing out here. So the mass and volume here, if we take, so that comes out to be 20 kg per cubic meter. So here we can say that within this within this particular cubical block, so the quantity of matter is 20 kg, which is present in a volume of 1 cubic meter. That is basically your density. Now if you talk about the overall thing, if you want to find the density of this cubical block, so in that case you need to find the mass of the entire block, and you need to divide this with the entire volume. So that will ultimately give you the mass present in per unit volume. Okay, so when we divide anything with any ratio, it actually turns out to be the unit thing, right? Now this density by default is nothing but your mass density. So mass density or mean density, sometimes we are calling this as a mean density or a specific volume. Okay, sorry, this is not specific volume, this will be specific mass rather. So please make a correction, this will be specific mass, that is the mass present per unit volume. Okay, so here we were talking about the overall density. Now let's say if we are interested to find the density at a particular point. So in that case we will take help of calculus and we will put limit, and then we will write limit mass by volume as volume tends to 0. Now what is the significance of this volume tending to 0? So let's say we have some cubical block out here which is having some volume V, and volume tends to 0. As you can visualize that this volume is slowly decreasing and ultimately reaching a particular point. So as a volume which is tending to 0, which means nothing but your volume is reaching to a particular point. Okay, so if your mass if you are interested to find the mass density at a particular point, then you need to apply this particular formula. So now let's summarize. We have said that mass density or mean density, density, specific mass, all are actually the same thing. So whenever nothing is mentioned with this density term in the left hand side, then by default it assumes that it's simply the density. So density means it's actually your mass density or mean density or specific mass. So mass per unit volume at a standard temperature and pressure. So that is why I have underlined it, because it varies with temperature and pressure. Okay, so at a particular standard temperature and pressure, your density value remains the same. So we can say that density is nothing but mass per unit volume, and the SI unit, if we talk about, it is nothing but mass. SI unit is kg. The mass volume SI unit is meter cube. So if you divide it, it will be kg per meter cube. So remember, what is the standard unit or SI unit or System International unit of density. Another type of density we come across is your weight density, also known as your specific weight, which is represented with a small letter W. So weight per unit volume at a standard temperature and pressure. So here we are talking about specific weight. So here small w is equal to capital W divided by capital V, and this SI unit will be Newton per meter cube. One more relation, that is omega. We know that a small w is equal to W divided by V. So we know that W is equal to M into G. Just now we have come across that mass by volume is called your density, rho. So we can write this omega as rho G. Now another density we have is volume density or specific volume, which is represented with small letter V. So volume per unit mass of a fluid is called specific volume. So small volume is equal to capital V by small m, and the SI unit will be meter cube per kg. Then we have relative density, and we represent it with RD. Many people represent it with some other notations, but I love the symbol, so I'll be using RD. It is the ratio of the density of one substance to another substance. Okay, so we are talking that the ratio of density of one substance to that of another substance. So let's say if you are interested to find what is the relative density of water with respect to alcohol. So whatever the term is written first, so that will come in the numerator, and whatever term is written in the last, so that will come in the denominator. So relative density of water with respect to alcohol will turn out to be rho of water divided by rho of alcohol. So we can call this the density of water to that of density of alcohol. Similarly, relative density of mercury with respect to kerosene. So density of mercury with respect to kerosene. Now, can you tell me what will be the unit for this? Of course, there is no unit, because it is a ratio of the same units. So density will be having the unit of, say, kg per meter cube. Density of alcohol will also have the same unit as kg per meter cube. Since this two are the ratios, so this will get cancelled out and no unit will be left out. Another property of fluid mechanics is your specific gravity. It is quite related to density, so that is why I have clubbed here. So specific gravity, we represent it with, say, with your letter, alphabetical letter S or Greek letter gamma. So many people represent it with some other notations as well. Many people represent it with some SG. So it totally depends upon you which notation you are following, but what is the concept behind this, that is important. So it is defined as the ratio of the density of fluid to that of the standard fluid. Now he will be asking, sir, just now you have explained the relative density, that is density of the one substance to that of another substance. Then what is the difference between the specific gravity and relative density? Many people get confused, as many people assume that yes, relative density is actually the specific gravity. No dear, the relative density is different, specific gravity is different. What is the difference? See here. Here also we have the ratio of the two densities, right? Density of one substance to the density of standard substance. Density of one substance to density of another substance. Okay, but here this another substance is considered as to be the standard one. Okay, so we can say that specific gravity is nothing but the ratio of the density of the fluid to that of the standard fluid. Okay, so you can say in a nutshell that your specific gravity is just a special case of your relative density, where the denominator has to be considered as to be the standard one. So here what do you mean by the standard fluid is the standard fluid for liquid. We know that fluid means liquid or gas. So standard fluid for liquid, we consider water as to be the standard fluid, and for gas we consider this air as to be the standard fluid. We consider this air as to be your standard fluid. Okay. Now we also know that omega is equal to W by V, which is mg by v. So m by v is equal to rho, so omega is equal to rho g. So this rho is directly proportional to this specific weight, which is omega. So instead of writing this relation, we can also use this relation. So it depends upon the numerical which is being given in the question, whether you can use this relation or this relation in order to get the value of anything, any one unknown thing out of these three. Okay. Now there are some important note points that you should keep in mind. That first note point is that the density of the liquids is actually constant, and the density of the gases change with variation of pressure and temperature except water. So here we are telling that the density of the liquids is constant, but the density of water is not constant. Why? Because water is quite exceptional. It shows anomalous behavior. Okay, so we have studied these things in your chemistry junior classes, class 4, 5, 6. So you should remember that the density, maximum density of water occurs at 4 degrees Celsius. At 4 degrees Celsius, the density of water is measured to be 1000 kg per meter cube, and the temperature below that or beyond that, the density will be quite lesser than this 1000 kg per meter cube. Okay, so sometimes in question you might have observed that sometimes the density they give as 991 or 998. Okay, so but one thing, if this 1000, if the density of the water is not given in the question, then by default we will assume this 1000 kg per meter cube for our calculation purpose. But if in the question they have strictly mentioned the density of water as some value, you are bound to take that. You are not supposed to take 1000 in that case. Okay, so according to the question we have to go. Now there are some important density values you should remember. So density of water we have is 1000 kg per meter cube. Density of gasoline is 700 kg per meter cube. Density of mercury is 13,600 kg per meter cube. Density of air is 1.21 kg per meter cube, and density of hydrogen is 0.0838 kg per meter cube. Okay, so these were some important things related to the fluid property called density and specific gravity. Hope you enjoyed and loved it and liked it and understood it well. See you in the next lecture. Till then, bye.